Morning to everyone. Myself CRJ Kumar. I am from CSC A section. Today I am telling about implementation of queue using linked list with an example. Implementation of queue using linked list with example. Introduction to queue and linked list. A queue is a linear data structure that follows the first in first out principle. In a linked list is a data structure consisting of nodes and where each node contains data and address a reference to the next node. Implementing a queue using a linked list allows dynamic memory allocation and efficient insert and removal of elements. Basic concept of queues. Queue are commonly used in scenarios like scheduling process and managing requests in service providers. The two primary operations of a queue are enqueue and add an element and dequeue removing an element. In a queue, the friend point to the first element and rear point to the last element in the queue. Advantages of using linked list for queue. A linked list based queue does not have a fixed size, allowing for better memory utilization. There is no need for shifting elements during insertion and deletion, making operations more efficient. The linked list is implementation can dynamic numerically grow or shining according to the number of elements in the queue. Structure of a node. Each node in a linked list queue containing data and a pointer to the next node. The structure of a node can be defined in programming languages like C, C++, or Java. For instance, in C, a node can be represented as a struct node, int data struct node. Queue structure. The queue itself containing pointers to the front and rear nodes. This enables efficient access to both ends of the queue for dequeue and enqueue operations. A typical structure can be defined as the struct queue struct node. Enqueue means add a queue element. Dequeue means delete a queue element. Enqueue operation. The enqueue operation adds a new element at the rear of the queue. If the queue is empty, both front and rear pointers will be point to the new node. If the queue is not empty, the new node is linked with the rear and then the rear pointer is updated. Dequeue operation. The dequeue operation removes an element from the front of the dequeue. If the queue is empty, it is typically returning an error or a null value. After removing the front node, the front pointer is updated to point to the next node in the queue. Example of queue operation. Let us consider a queue with the example element 10, 20, 30. After enqueue 40, the queue becomes 10 is the front, 20 is the middle, and next 30, next 40. Now the rear end will be the 40. Performing a dequeue would remove the 10, adjust the queue to the 20 front, 30 rear, and 40 will be the rear. Implementation example in C. Here is a simplified example queue operation in C. Void enqueue. Queue int value. In braces node, temp is equal to node. You can see in the picture like example program. Dequeue operation and enqueue operations is there. Conclusion. Implementing a queue using a linked list is an efficient way to manage dynamic data. This approach provides flexibility in size and performance advantages over array-based implementation. Understanding the queue operations and linked list structure is crucial for effective data management in programming. Feel free to use or modify this presentation as needed. Thanks for giving this opportunity.